34 f of x, the square root of 2 plus natural log x. Excellent. Very good. Okay. So first of all, we are asked to find a domain of both functions, right? They're asking us to find the domain of f, and then after we find f prime, to find the domain of f prime. Okay. How do I start for the domain first? What do I have to write in order to find the domain of this function?
X is greater than 0. No.
How do I find the domain of a square root? What do I have to do? What do I have to write?
The absolute value of X.
So not to be confused with this. We're not talking about this. We're talking about how do I find the domain of a square root? Where is my starting point? What do I have to state before I come up with a domain?
Oh, X cannot be equal to 0.
I don't have x. I'm looking at this.
Okay.
So I have the square root of a function or the square root of a quantity. How do I find the domain of this function? What do I have to write first? Anyone remembers? What do we need to write? For the square root to exist?
I mean, I could have sworn we said that every time, if we're dealing with the square root at any time, that x must always be greater than 0, greater than or equal to 0.
If I have this, but this is not what I have. Perfect. But only if the function is this.
Right.
But this is not what I have.
But we're talking about domains, so we're only talking about the x. We're not talking about y. If we were talking about the function, we'd be worried about y. So that's why we're worried about the x. That's why we keep going back to x.
So what do I have to write? So if I have the square root of x, indeed this is correct. Perfect. I don't have the square root of x. I don't. I have the square root of 2 plus natural log x. So what do I need to write? By comparison, what will you tell me to write? Because if I don't write something, I don't know how to come up with a domain. But what do I need to write first? So for this, you gave me this condition. Excellent. But what condition will you give me for this?
2 plus natural log X must be greater than or equal to 0.
Yay! Thank you. Now, my next question is, how do I solve this? Perfect. That's the conclusion. That's my starting point. Awesome. Now, how do I solve this? What do I have to do here? Forget about the rest. Now we are focusing on this. What do I have?
The operator. So natural log x must be greater than or equal to -2.
Awesome. Perfect. Stay with me. This is not as easy to solve as other inequalities, but I'm going to graph this. Do we know how this looks like? That's why we reviewed all these basic functions, so we don't have difficulties later. Do I know how to graph this piece?
Yes, it starts in quadrant 4, which is where you're pointing. There you go.
Excellent. Thank you very much. So I graph this. Do I know how to graph this? So
yes, the straight lines are horizontal.
excellent. Great job. Thank you very much. So this is y equals -2. And now what do I want? I want the natural log to be above -2, or I want natural log to be below -2, because these are the only two options. Only above or below.
Above.
Yes. So then this inequality will have solutions from the x value of this point all the way to the right, where the orange function is above the brown function. Do we all understand this step? You see this point here. So from this x value to the right, the orange function is above the brown function. Yes? We agree?
Yes.
Excellent. Excellent. So now all I really need to determine is this x. So I'm going to set them equal to each other. I'm not changing the inequality into an equation. I solve the inequality graphically, but I need this x value. How do I determine that x value? By simply setting these two equal to each other. Again, I'm solving that, but I need this first. How do I solve this in this equation? What type is it?
X equals
Linear.
It cannot be linear if it has natural log. The moment you read it in your head, natural, if I say natural log x equals -2, I can no longer say linear. I cannot say quadratic. I cannot say rational. I can only say natural log. It's a log equation. Good. Now, after we establish that, how do I change this? There's an equivalency here. Natural log equals a -2. Remember, what is the base of natural log? I don't see a base. E, very good. So e raised to this number equals x. Always start with the base, go counterclockwise. E to -2 equals x. So then x equals 1 over e squared. So this value here is 1 over e squared. So now the domain of this function is 1 over e squared, comma, infinity. Very good question. Is this clear? We went to tons of steps here. So let me emphasize just real quick how to find the domain of a radical function, in this case quadratic, square root. How to solve a natural log inequality. How to solve a natural log equation. How to convert a natural log equation into an exponential equation. And also how to graph natural log, and this is very clear, it's a horizontal line. So a lot of steps. This is coming from algebra and pre-calculus, a lot. Do we understand the domain now? Every step, yes, no. Is it a yes? Is it a no? Do we have questions?
It's a yes for me.
Good. So now let's find the derivative. So f prime of x. Remember, we have the square root of a function prime. Can anyone remind us the formula? I'll write it here.
1 over 2 times the square root x times.
We're talking about a function.
Times the function prime.
Exactly. Awesome. So then I have 1 over 2, the square root of 2 plus natural log x times the inner function prime. Can anyone give us the inner function prime?
1 over x.
Excellent. So if you want to rearrange it, you can. It's like 1 over 2, the square root, 2x, 2x, the square root of 2 plus natural log x. So now we want to find the domain of this function, which is different than the domain of the original function. We know that x cannot be 0, but there is no problem because the function is not defined at 0 anyway. So this is not even remotely needed because the function is not defined there. So its derivative cannot be defined. If the function is not defined at 0, its derivative cannot be defined. But now, what changes here versus what we just had a minute ago? Can anyone give us an idea? What changes? What is different?
Now x cannot be 0.
We're not talking about x. We do not have the square root of x. We can analyze x if we have the square root of x, but we do not have the square root of x. So what changes and what do I have to write now?
So now it's with respect to 2x over 2 plus natural log x. Okay.
So this is not a problem, this is not a problem. We are only talking about this piece. So what is different from before? That changes things. Okay, let's look again at the function. Look at the function and look at its derivative. What is different? When it
Just the
comes,
inverse,
you want to say multiplicative inverse?
multiplicative inverse.
I agree. So then what changes? Do I write the same thing? Do I write something else? I completely agree.
So it's with respect to 1 over 2 plus.
But I don't state domain of the numerator. So when I state a domain of a function that has a ratio, I don't look at a numerator unless it's a square root of something or a natural log of something. So if this is 1, we never look at the domain of this function if this is a number. This never comes into play. So what is different from here with this and here? What do I have to write? You notice perfectly what is different. So then what do I write? I have to find, I'm asked to find the domain of the function that is the derivative. So what do I have to write? Anyone would like to help? RJ, Rihanna, Gia, Janelle, Ethan, Isaac, anyone? What is different? What do I need to write at this point?
Would you write that it's greater than or equal to 0?
But can I? And first of all, what? What do I write? Can anyone dictate what to write? What will you write? Just to tell me what you would write. Anyone? So what is the problem? Because I want to understand what am I not saying here so that apparently it's not clear. Because by now we would have finished this in 3 seconds, but something is not clear and I blame it on myself. I don't say something for you to understand. Anyone?
We reference back to the 1 over e squared. I know that's our original domain. And do we reference back to that now? Because we're still using square root of 2 plus natural log x, or do I do the square root of 1 over e squared then? I'm not sure. That's where I'm confused.
Okay, how did we write the domain of the square root? What did we write?
But for the domain of the square root, or not even square root, because we didn't even use
This,
the
for
square
this
root.
function, we're talking about this function. What did we write?
We didn't do the domain of the square root. We only did the domain of the inner body of the square root. So we only did the domain of 2 plus natural log x.
No, we did the domain of this function because it's required that under the square root to have positive or 0. This is what we did.
Okay.
If there is no square root, then the domain will be just x greater than 0. The square root tells me that I have to write this. We did not state the domain of this. We stated the domain of the square root. The square root imposes this condition.
Okay.
Perfect. So now that was probably what I didn't say clear enough, obviously. So now look at this function and how do I write, what do I need to write to find the domain of this function? So nothing about this, nothing about this, because x cannot be 0. And we know that x cannot be 0. 2 is just a number. So we are focusing again on this quantity. What do I need to write to make this quantity exist? And it's the square root, yes? And Sean noticed that this is in the denominator now. So something must be different. Here it was not in the denominator, but here it is. So something must be different. The location of that square root changes the domain.
Are we just looking at the square root then 2 plus ln of x? And then greater than 0.
That's it. Because it's in the denominator.
Yeah.
Thank you so much. Thank you for saving us. The square root now is in the denominator. Therefore, this quantity still has to be positive, but this time cannot be 0. So the only thing that we have to exclude from this domain is this number and make it open. And that will give us the domain of the first derivative. Only because, as Sean said, the position now of this square root is in the denominator. So the domain of f prime is, there is no need to move this and solve again. I already have the answer. It's 1 over e squared comma infinity. That's the only difference, the position of the square root. That changes everything. So the function is defined at 1 over e squared, but it has a vertical tangent there. That's why the derivative is not defined at that point, because this cannot be 0. Good, very good question, good analysis. These discussions helped me understand what I didn't say. So maybe something, I've been teaching for 20-some years. I have yet to meet one class that likes the square root and will say right away, oh, it's this, and solve, and that's it. I don't know why. What's wrong with the square root? Something must be happening with the square root. Good question. Sean, is this clear, every step?
Yes.
Excellent. Other questions, please?